Hello everyone, my name is Poojitha and today I'm going to explain about the topic called types. What do you mean by flip-flops? In digital electronics, a flip-flop is a sequential circuit with two stable states used to store one bit of binary data, that is 0 or 1. It acts as a basic memory element that can hold and maintain its state until changed by an input signal, typically triggered by clock pulse. Flip-flops are fundamental building blocks of memory devices and are widely used in registers, counters, and shift registers. There are several types of flip-flops, including SR, JK, D, and T flip-flops, each with specific functions and input-output behaviors. The name flip-flop comes from its ability to flip or flop between its two stable states, storing and controlling data in digital systems. Applications of flip-flops. Flip-flops play a crucial role in modern digital systems, serving as essential components in registers, counters, and synchronization circuits, enabling efficient data storage and timing alignment across various applications. First one is SR flip-flop. An SR, that means set or reset. Flip-flop is a basic type of flip-flop used in digital electronics to store one bit of data. It has two inputs, that is SR. S means set, R means reset. When this input is activated, that is S, the flip-flop sets its output to 1. When R input is activated, the flip-flop resets its output to the 0. The SR flip-flop operates with two stable states. By truth table, we can understand this. If S equals to 1 and R equals to 0, the output Q is set to 1, set state. If S equals to 0 and R equals to 1, the output Q is reset to 0, that is reset state. If both S and R are 0, the output remains in its previous state, that is memory state. If both S and R are 1 simultaneously, it is an invalid or indeterminate state in basic SR flip-flops. It can be built using cross-coupled NOR or NAND gates and is fundamental in memory and sequential logic circuits for storing and controlling binary information. Understanding the SR flip-flop functionality. Here, SR flip-flop operates through two inputs, that is S and R, which controls its output state, that is Q. As we saw the truth table, here when S equals to 1, we know output Q is set to 1. If R is equals to 1, the output Q is reset to 0. Here, if both S and R are 0, the flip-flop retains its output state, that is called hold state. A significant limitation arises when both inputs are 1, which lead to an invalid input condition. If both S and R are 1, there we doesn't consider any type. SR flip-flop is commonly used in basic memory storage applications, providing a straightforward means to store a single bit of data securely. Now let us see the overview of JK flip-flop. The JK flip-flop is a type of sequential logic circuit used to store one bit of data with two inputs labeled J, that is set, and K, that is reset, and two outputs Q and its complement Q bar. It is an improvement over the SR flip-flop, resolving the invalid state problem when both inputs are high, that is when S equals to 1, R equals to 1, there we are getting invalid state. To resolve that, we use JK flip-flop. The JK flip-flop operates with the following input conditions. Understanding JK flip-flop behavior. The JK flip-flop is a versatile memory element that operates effectively in sequential circuits. Inputs J and K determine the output state. Here the toggle action is when J equals to K equals to 1 during the clock pulse. The Output Q toggles switching between 0 and 1. Stable states are if J and K are both 0, the flip-flop maintains its previous states. Use case. Ideal for counters and frequency division, providing reliable toggling without invalid states. Understanding the race around condition in JK flip-flops. Here, the race around condition arises when both inputs are set to 1 during a high clock pulse. This results in uncontrollable toggling of the output Q as flip-flop continuously switches states. It doesn't have a stability. It continuously switches states. To address this issue, the master-slave JK flip-flop configuration is implemented, where one flip-flop master captures the input during the clock's high phase, while another, that is slave, reflects the output during the low phase. This separation prevents the race condition and ensures stable output by effectively controlling the timing of state changes. The overview of D flip-flop. The data or delay flip-flop is a type of clocked flip-flop used to store a single bit of data. It has two main inputs, D and a clock. On the triggering edge of the clock, usually rising edge, the output Q takes the value of the D input. The output Q holds this value until the next clock edge effectively latching the data. It eliminates the invalid state problem of the SR flip-flop by having a single data input, simplifying control. D flip-flops are commonly used in registers, memory storage, and data synchronization tasks. They can be built by modifying an SR flip-flop with complementary inputs or by combining two latches in a master-slave configuration to avoid timing issues. The characteristic truth table is simple. When the clock triggers, output Q equals to D. Otherwise, output remains unchanged. Here, the D flip-flop is essential for reliable data storage in electronic systems. The functions capturing by the value of data input is on the rising edge of the clock signal. The flip-flop is widely used in registers and memory devices, providing a straightforward method to store bits. The key advantages are it eliminates invalid states found in SR flip-flops, simplifies data handling in synchronous. Here in this application improves reliability of data storage in digital circuits. Now let us discuss about the last flip-flop, that is T flip-flop. A T flip-flop is also known as a toggle flip-flop. Is a type of flip-flop circuit that toggles its output state when its input T is high, that is 1, at the time of a clock pulse. When the T is low, that is 0, the output remains in its previous state. Essentially, it has one input, T, and changes the output state on the active edge of the clock signal based on this input. Key points about T flip-flops. If T equals to 0, the next state output Q remains the same as the present state. If T equals to 1, the next state output Q toggles, that means complements from its current state. It can be implemented by connecting the J and K inputs of a JK flip-flop together and using them as the T input. Its characteristic equation is a Q next equals to T nor Q, where that symbol is the XOR operation. Common uses include frequency division, that is dividing clock frequency by 2, and as a binary counter element. It is edge triggered, changing output only at the clock edge, that is rising or falling depending on the T flip-flops. The T flip-flop is a simple memory element that either holds or toggles its output based on the toggle input and clock, making it useful for toggling, counting, and dividing frequencies in digital circuits. By this, I conclude the topic. Thank you.